come into play. We're really only talking about sine and cosine today because we've said that those are used to model waves, right? And so you see that a lot in a lot of the different sciences, using sine and cosine to model different things. So one example is like a spring. You know, if you have a spring with a weight attached to the bottom, all right, if I pull that spring or the weight down and let go, what's going to happen? Okay, it goes up, and it doesn't just go up and stop, right? It goes back and forth. So that could be modeled with a sine or a cosine type function. It's because it oscillates like around that equilibrium, that it'll go above it and below it. That's one situation where it's used. We're just talking about the most basic, simple harmonic motion, so only dealing with sines and cosines. We know that amplitude is just the number in front, the A, right? The period is how long it takes to repeat. How do we find period for sine and cosine? 2 pi over b, which in this case they used omega. It's just what the variable that they typically use in this, same thing as having a b. The only difference is frequency. Period is how long it takes to repeat. Frequency is how fast is it repeating, so it's just the reciprocal of your period. Okay, so if I said it has a period of 4 seconds, it takes 4 seconds to do it, then the frequency would be 1/4 of a rotation per second. Okay, so they're just reciprocals. Those are really the only words that we're going to talk about in this. So if we take a look at this one, suppose an object is attached to a coiled spring. It's pulled down 5 inches from its equilibrium position and then released. The time for one complete oscillation is 4 seconds. Right, give an equation that models the position at time t. So my amplitude is going to be what?
1.
It's how far above or below the center line, right? 5. Okay. I also know that this one begins down because I pulled it down. So is that a sine or a cosine? Sine always starts where? In the middle. So it would have to start at its equilibrium and then go from there. This one, I pulled it down and then released it. So it started from its low point, right? That's more like cosine, except cosine typically starts at its high point. So how would I make it start at its low point? A negative. Okay. Position, the variable for position is sometimes s, so s of t is position at time t. I'll use that a lot today. If you did y or something, I'm not going to count off. We know it's a negative because it started down, and a 5. Most of these are going to be cosines because you have to get something to move to start with, right? So I have to pull it down or push it up to make it start moving. All right. So now we just need to figure out what's with my variable here, my time. We know the time for one oscillation is 4 seconds. So that's giving me my period. My period is 4. So when I do 2 pi divided by, you can call it b if you want to use the notation we have been using. In this section, they use an omega. It's the same thing. This has to equal 4. So if I divide by 4, my omega is pi over 2. So my equation is -5 cosine of pi over 2t. Is that okay? So we've really kind of written equations before. We're just seeing different words in this one. Determine the position at t equals 1.5 seconds. All right, so I have an equation. And I'm plugging in 1.5 for my time. You can use a calculator, I don't care, but make sure you're in radian mode if you're going to type this in. And make sure you put in the whole thing. -5 cosine pi over 2 times 1.5. What do we get? You need parentheses around the whole pi over 2 minus 1, or times 1.5. Okay, that's my position. We were measuring in inches. So what this means is it's 3.5 inches above the starting point. So the spring is up here right now. Part C, find the frequency. We know frequency is just the reciprocal of period, right? Did we already know the period on this one? Yeah, the period was 4. So my frequency would be 104. And that's just like oscillations per second. So in 1 second, it's only gone a fourth of the way. Okay, some questions right there? It's just the reciprocal of the period. So we already knew the period was 4. You could also think period is 2 pi divided by the number in front of x. So this would flip it. It would be the number in front of x divided by 2 pi. It would give you another way of finding it. Do you flip the multiplier? So we did it both ways. Anything else? All right, so this one, I gave you the equation to start with. I'm just asking you some questions about this one. So describe its movement. It's a sine function, so what could you tell me? Where does it start? It starts at 0. And then what does it do? Go up or down? Because it's a positive 8, right? We know sine starts at 0 and then goes up. And negative would have flipped it, but we didn't have that here. All right. Let's talk about what is the amplitude. 8. What is the period? It's 2 pi divided by 3, right? If we want to be more specific, our amplitude is the height. It did say that was feet. So it's either going to go up to 8 feet or down 8 feet. Period. That is the time. So it's basically saying it takes 2 pi over 3 seconds per oscillation. What is the frequency? And that would be oscillations per second. Those are just reciprocals of one another. Let's look at another one. A weight on a spring has an initial position, S of 0 equals 2 inches. That's meaning at time 0, the height is 2. Is that sine or cosine? Cosine. Sine has to start at 0 since it didn't. This is a cosine function. Okay. Since it started at a positive 2, was it flipped? No. All right. What would my amplitude be? 2. So it would have to be a 2 cosine. Okay, my period is 0.5 seconds. So we know period, 2 pi divided by the number in front of x has to equal 0.5. So if I divide my 0.5, what do we get? And you need the time, the variable with it. So my S of t is 2 cosine of 4 pi t. That's my function. Right. Part B, evaluate S of 1. So 2 cosine of 4 pi times 1, which equals what? 2. All right. Is the weight moving up, down, or neither at that point? So think about what we know here. This is a cosine function, right? So it's just going like this. We know that the period was half a second, right? So when it got to here, that was 0.5 seconds. When it got back up there, this would be 1 second. So we wanted to know at 1 second what's happening. Well, at 1 second, is it going up, down, or neither? Neither. We went up and we're getting ready to come back down, but at the moment, I'm neither one, right? I'm just at the top. Okay, and we know that then just from that little picture that I drew. We knew it repeated every half a second, so after 1 second, we're at the top of our peak. We're ready to begin the next cycle, but we haven't done it yet. When does it hit its maximum height? Okay, what is the maximum height? 2. When does that happen? We started there. When do we hit it again? 0.5 seconds. Okay, that's how long it took for us to get back to where we started. I would like for you guys to look at the next question and see if you can write the equation. Do we know if it's sine or cosine? Sine has to start at 0. Since this one started at a height of 0.21, it is a cosine. Because at time 0, the only way you'll get a sine is that at time 0 it's equal to 0. What's my amplitude? So we have a 0.21 cosine. Okay, frequency is 27.5. That means, what is the period? So think about how we find period. 2 pi divided by the number in front of t is equal to the period. So that means my omega is 55 pi. So it's 0.21 cosine 55 pi t. Does that make sense? So it's kind of taking stuff that we've done before, but we're just attaching different words to it. Okay, we haven't talked about frequency before, but if we know the frequency, we know the period. We just think 2 pi over that number in front of x. So what I want to do now, we have quite a bit of time. On the chapter 4 homework, there is a section 4.5, so I want you to work on that. If you finish, I do have the study guide, so you're welcome to go ahead and grab a study guide as well. But do these first, make sure you're asking questions.